So 9, 10, and 11 from worksheet 5. Number 9, completely new graph. We've never seen that thing before. Which of the following is the graph? I think there does need to be a correction. This needs to say theta is greater than or equal to 0. Now, I have no idea what that looks like. That's not one of our parent functions. So I think my best bet is to just plot some points and see who matches up. So let's start with 0, and we'll just start seeing which one matches. So 3 over 1 is 3. So that means I need a point at 3, 0, where I rotate 0 and go out 3. So graph A is out. Graph B does have that point, if I call it point A. Graph C has that point. And graph D has that point. So that didn't help too much. I mean, it threw out one of them. So let's pick a different point. Let's try pi over 2. Now the trick though is 3 over pi over 2 plus 1. What? I don't know what that is. So I need to get some decimal approximation for pi over 2. Well, pi is 3.14. So pi over 2, I mean, for this purpose, we can probably roughly call it 1.5 and be good enough. So 3 over 1.5 plus 1. 3 over 2.5 is a little more than 1. If you want to get a little more accurate, 1 and 0.5 over 2.5, so that's like 1.2. But a little more than 1, I think, is going to be good enough. So if I rotate pi over 2, A's already gone, rotate pi over 2 and go out a little more than 1. Whoops, so B is out. Rotate the pi over 2, go a little more than 1. C still in. Rotate the pi over 2 and go a little more than 1. Okay, I don't think D is right because there's a whole lot of points in between A and B that we would not have gone through. So I'm pretty sure C is right. But if I wanted to check one more point, maybe I could check pi. So let's do one more point. So 3 over 3 plus 1, 3/4. So that means I should rotate pi and go out 3/4. Rotate pi and go out 3/4 would be right there. D's out. Rotate pi and go out 3/4. So I definitely think C is the answer. Yes, sir. Okay, it's going, I wouldn't say it's going backwards. As theta gets bigger, R is getting smaller because we're dividing by a bigger and bigger thing. So as we rotate around, because we're going this way, as we rotate around, R is getting smaller. There's if we stopped at 2 pi. If we kept going another 2 pi, we'd get smaller and smaller still. Something like that. And another 2 pi, and so on. All right, number 10. Which of the following is the graph of 3 sine 2 theta on this interval? Maybe I should back up. I know what 3 sine 2 theta looks like. That's a 4-petaled rose, not on an x-axis. So there's what the full graph looks like. And now this question is, well, which petal is it between pi and 3 pi over 2? Last period, I just jumped in and started plugging in points. Someone else had a different idea? Thoughts on how we could figure out? Pi to 3 pi over 2, that would be in the third quadrant. Oops, pi, 3 pi over 2, pi, 3 pi over 2. So where is the graph in the third quadrant. It looks like C, but I have to be careful because if R is negative, that would bump it into the first quadrant, right? So I think it's C, but if R is negative, then it would be B. So I'm pretty sure it's not A or D. If R is positive, we're in the third quadrant. If R is negative, we're in the first quadrant. So I need to put some points in. From pi to 3 pi over 2. So I guess let's just start at pi. 3 sine of 2 pi is 0. That doesn't help because they all have a pi comma 0. So let's try, which I think 3 pi over 2 is also going to be at 0. So let's pick something between pi and 3 pi over 2. So that'd be 5 pi over 4. So 3 sine 2 times 5 pi over 4 would be 5 pi over 2. What's coterminal with 5 pi over 2 though? I don't want to worry about where 5 pi over 2 is. What's coterminal? What's the same spot as 5 pi over 2? Pi over 2, because I can subtract 2 pi. So that's the same thing as pi over 2. Sine of pi over 2 is 1. 3 times 1 is 3. So if I rotate to 5 pi over 4, I should go out 3. So if I rotate to 5 pi over 4 and go out 3, there's nothing there on B. Rotate 5 pi over 4 and go out 3. Yeah, it's C. Again, in my mind, those are the tricky AP style questions because they're either graphs you haven't seen before or they're asking for a piece of the graph. Number 11, graph of that function is shown in the xy plane, and we want to translate that into a polar picture. Here's another one where me in third period opted for different processes. What would you do on number 11? I'll show you what I did, and then I'll show you what they did, and you can pick whichever one you like better. I'm just going to go point by point. So that point is 0, 1. That's a little bit out of order because we like to put the R first, but if I'm just scratch paper working this thing. So rotate 0, go out 1. The furthest out I'll go is 3, so I can kind of set my scale based on that. Okay, so rotate 0, go out 1. That puts me right there. Point A. Point B would be rotate pi over 2 and go out 3. Rotate pi over 2, go out 3. So there's point B. Point C, rotate pi, go out 1. Rotate pi, go out 1. There's point C. Point D, this is going to be a little bit weird because I'm going to rotate 3 pi over 2 and then go out -1, or sort of go backwards 1. So if I rotate the 3 pi over 2 and then go backwards 1, that puts me right there. Do you know what shape is going to go through that strange set of points? The one with the loop, the limacon with the loop. Maybe I should be careful. Point A and point E would be the same. Limacons with the loop, it's best to just do the outer loop and then do the inner loop. And remember, include the origin as a point. So outer loop, inner loop. I don't know if it matters, but that inner loop, that negative, when it drops negative below the x-axis, that means it goes backwards on the polar graph. So that negative piece corresponds to the inner loop. Okay, there is a slightly different way to work that problem. some people might like. I think if you know your equations really well, it's faster. But if you don't know your equations well, this is probably safer. So the equation way would be, well, look at that picture. I know that equation. That's y equals, that looks like a sine wave. Regular period is 2 pi. Amplitude is 2. And the shift is up 1. Well, if I replace that with polar stuff, 2 sine theta plus 1. So the loop part's bigger than the circle part. It's a limmason. Maybe graph it that way. So if you're good with equations, do it the equation way. If not, do it by points.